Hello and welcome to a sub-series of uh, problems on Leetcode that you basically have to know to use as frameworks for other more difficult problems on Leetcode. This specifically is question 300, longest increasing subsequence, which will be utilizing the dynamic programming approach. Let's begin the problem. Given an array of nums, return the length of the longest strictly increasing subsequence. There is a slight difference from a longest strictly increasing subsequence to strongly increasing contiguous subsequence, where in this question you are not observing subsequences as slices of an array. You're just picking out random numbers in order, obviously, that happen to be greater than the previous. So in nums, for example, we have 10, 9, 2, 5, 3, 7, 100. If we were to do the longest contiguous increasing subsequence, it would be 3, 7, 3, 7, and 101. However, in this situation, we're tasked to find the longest increasing subsequence, which doesn't have to be contiguous. So 2, 3, 7, 100 is actually the correct answer. Let's look at why the approach for finding the longest contiguous subsequence won't work here. This is a very sort of easy example of getting stuck on a local maximum. Let's say that we have a pretty simple sequence 1, 2, which would be the longest subsequence of this array. All of a sudden we have let's do 10, 11, 12, 10, 11, 10, 11, 12, which is now the current longest subsequence, 5. But then, all of a sudden, we have 3, 4, 3, and 4, and that's it. These 3 and 4 would form the longest subsequence if we were to include the 1, 2 in here. No. No, we would need also 5 and 6. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is greater than 1, 2, 3, 4. To make it easier, let's do this. Yep. All of a sudden, we have to scratch this subsequence, remove this completely from the subsequence, and append this instead. So how do you keep track of all, essentially, all subsequences up until the time where you start to consider new ones? Well, in this case, we could keep track of the longest subsequence ending at here, which would be 1. The longest subsequence ending here, which would be of length 2. The longest subsequence of length this, or ending here, which would be 3, and so on 4, until we get to this number, which in this case we don't actually know what the greatest subsequence, the longest subsequence is, unless we know both of these information. We need to know which number is this number strictly bigger than, and we can check that it's not bigger than 11 or it's not bigger than 10. Therefore, these longest subsequences aren't good enough for us. And then our next check is to check, obviously, the next integer, which 2, which happens to meet the criteria of this being bigger than this. And so we can say that it's back at 3. Same goes for 4. 4 will be checked against 3, which is bigger, and 5. And so we get that the longest increasing subsequence is 5. I'm pretty much giving out the answer to this right here. We obviously need a max length to return. We're going to set that to 1. We're going to have this array populated with, let's say, longest ending at. We're going to populate it with ones of length nums, and we're going to say that for end in array. The end, or let's call it the current. The current is going to be the one that we're currently looking at. Here, when we just start the algorithm, we're going to be looking at 1, then 2, then 10, then 11, then actually no, we'll start at 2, because the longest ending at 1 is always 1. We'll start at 2, 10, 11, 3, 4, and 5 until we reach the end. So current in range 1, 2, cln nums, and now we're going to have the prev. The prev is going to be, for example, when we're observing 3, we're going to go through all the previous ending subsequences and make sure and find the one that fits us best. For prev in range 0 to cur, we're going to say that the potential for being the new longest subsequence is just going to be the longest at prev plus 1, right? Because if we're looking here, the potential for the longest would be this, any one of these plus 1, right? So we have the potential, and now we have the condition. So if nums of the current is bigger than nums of the prev, and the potential is bigger than the one that we're looking at currently, cur, then we're just going to say longest is now our potential, I spelled it potential wrong. And if potential happens to even beat our max length, then max length is equal to the potential. And that's it. Return max length. See if this runs. Perfect. Let's see, submission. Sweet. Yep, beats 62%, which means that the algorithm is probably correct. Let's see what a nicer solution is. Ants. I don't want to use any other libraries, so bisect. Okay, what about this? Actually, okay, for the purpose of just finding out the way of thinking about this is totally acceptable. This is actually the preferred solution on Leetcode as well. So yeah, I'm going to leave it off at that. This is a series of, I would say, problems that will be utilized in other more complex questions later on. So these are definitely worth knowing and definitely worth understanding more. Making these videos because I want to explain it not only to myself, but only to others, and for me to be able to look back at these and make adjustments as I develop more. Thank you for watching. See you later. Bye.